functions today. So what are functions? The idea of functions are they're a relationship. The relationship between the idea of an input and output. You're going to plug in a number, the function is going to do something to it and give you that relationship y value. So we have a couple ways of writing the idea of a function. We have, let's say, a simple idea of y is equal to 2x. We come up with a table, and a table will help us log all our interactions. I'm going to plug in input. I'm going to output. If I input an x, what will the y value result? So we're going to write this a couple times, give you guys number -2, 0, and +2, and we'll see what happens to this. So when I plug in the y, you could write, and I'll do this once. All right, y is equal to what? 2x. Y is equal to 2x. Y is equal to 2x. So what is the x for this level here? For this problem, what is the x that I'm using? Well, didn't we say x was -2? So instead of writing x, the letter, we write the number 2, -2. The next line, x became 0, and the last line, x became 2. So the idea is, instead of writing y equals to 2, plug in -2, y is equal to 2, plug in 0, y is equal to 2, plug in 2, right? Like what we would do here. I'm writing in this nice table so we can keep all our numbers organized. This becomes -4, 0, and 4. Now, let's go back and talk about what really is happening. This function, this relationship, takes your number x and it just multiplies it by 2. And did that happen? If I plug in -2, -2 times 2 becomes -4. Okay, we doubled it. 0 times 2, well, double nothing is still 0. And 2 times 2 gives us the 4. So this simple relationship says, hey, you're just going to double your values. Now, a couple other words we want to bring up. This is what we called another term. Instead of using the word input and output, we use the word domain and range. Okay, whoops. Range are your output values and domain are your input values. Sometimes we also call this dependent and independent. Okay, independent is what you plug in because it doesn't matter what you plug in, but dependent means it's based on what you plug in. So our range and domain, the domain is our x values and our range are the y values that come out of that. Okay. So we'll see this in one more way right here. If I write domain and range, for the problems that we plugged in, draw 2 boxes here. The possible x's we used were 0, -2, 0, and 2. And the possible answers we got was -4, 0, and 4. And these were connected. Right? -2, I plugged in -2, I got -4. I plugged in 0, I got 0. And when I plugged in 2, I got 4. So we just looked at 3 different ways of looking at the same exact problem. You can give someone the function, you can give someone the table of values, or you can tell them the plugin and results. Okay, let's go ahead and look at another example here. Well, what do we do with these numbers? The idea is that y equals to 2x works for all x's. All x's. So couldn't we plug in 3, 4, 5, 6? Couldn't we plug in 10? Couldn't we plug in 100? Yeah. And you could actually write all those values down. But let's look at this a different way. If I have my points, we have something called an ordered pair. That's a big word, ordered pair. And an ordered pair is a set of x and y values. Why do we call it an ordered pair and not just a pair? Because order matters. If I give you a point 0, 2 versus 2, 0, will these be different on an x and y table, x and y graph here? So if you guys haven't learned how to graph yet, in our horizontal direction, we always call that x. In our vertical direction, we always call that y. Now, why do we do that? I don't know. But everyone agreed to it. So in our x direction, we can fill out numbers like 1, 2, and 3. Negative on the left side, -1, -2, -3. And this is kind of like our one-dimensional number line. 1, 2, 3, 0, 1, 2, 3, -1, 2, 3. In our y direction, try to balance it out the same. Try to keep it about the same distance as you did in x. 1, 2, 3, 4. -1, 2, 3, 4. So instead of just dealing with a one number line now, we're dealing with two directions. It's almost like you used to be a worm and you can only crawl on the ground. Now you're a bird. You can fly in the sky. So not only are we on the ground, but we're also in the sky, we're in underground. Okay, so let's look at this point. So whatever number is your first number, that's always your x, and your second number is your y. First number is x, second number is y. So let's see if this actually matters at all, whether the order matters. So if I plug in 0, x is 0, up 2 spaces, this is 0, 2, where x is 0 and y is 2. My next point, 2, 0, x is 2, see x is 2, but y is 0, so I'm not allowed to rise up or go down. This is 2, 0. And these are totally different points. Let's talk about input and output. Imagine if this was your job. You worked 0 hours and you made 20 bucks already. That's cool. But what if I worked 2 hours and I made $0? Who wants to work that job? So order totally matters. And in the real world, we see order mattering all the time. When you start your car, do you step on the gas first or do you turn the key? Right? You have to turn the key first. First name, last name. Is not, sometimes it's last name, first name, sure. But there's a way of writing, my name is Edward Co. But if I want to write it backwards, you always write a comma. So everyone knows that order matters. Can Edward last name Co come out versus can Co last name Edward come out? So this order pair idea allows me to graph points, our input and output values. So let's go back to our easy y is equal to 2x problem. We had a table, x and y. We plug in the values -2, 0, and 2, and they give us -4, 0, and 4. Well, these are all ordered pair now. X is -2, y is 4. Whoops, that's ugly. X is 0, y is 0. X is 2, y is 4. And we can now graph those points, -2, -1, 2, 3, 4. Here's -2, here's -4, and they meet at point -2, 4. Graphing 0, 0, that's right in the middle. 0 spaces to the left, 0 spaces to the right. And then last one, 1, 2, 1, 2, 3, 4. 2, 4. Okay, now if you graphed your graph nicely and everything is balanced, your tick marks aren't too far away from each other, everything's equally paced. If I take my ruler now, everything should line up and we can draw a line. Now, what does that line represent? And the idea of this line, it's not just because we saw 3 points and we're drawing a line between them. The line is the physical representation of all our possible answers. Remember how I said you could plug in 1, you can plug in 2, you can plug in 1,000, you can plug in 100? Yeah. And the graph tells us if I did plug in 1, my answer would be 2. If I plugged in 3, if I plugged in 4, I would end up with answers that would be on the line. Like if I plugged in 1, this looks like 2, 1 comma 2. If I plugged in 3, this looks like 6 over here, 3 comma 6. If I double check them in my equation, 1 times 2 is 2. That's what we said. 3 times 2 is 6. Hey, that's what we're going for. And the line is all the possible answers without me having to actually calculate them. The line is actually made up of tiny little dots of all the possible decimal answers. Okay. So we'll revisit that a little bit later. But today, we're going to focus on just graphing points and talking about the domain and range. Okay, let's move on slightly and talk about domain and range. So let me give you some points. So domain and range. So remember, domain and range is x and y's for us. So here's some points. Here's my example. 3, comma 2, 5, comma 7, 6, comma -2. So we have 3 sets of ordered pairs. I want you guys to put domain and range. Draw the 2 boxes. So what were the possible values of x for these 3 points I picked? What were the possible values of x? Possible values of x were 3, 5, and 6. See, these are the only x values I'm allowed. It's almost like when you go out to dinner and there's a menu. You look on the sheet and say, hey, they have carne asada, they have enchiladas, right? These are things on the menu. That's my menu right here. Look at what's on the menu. And the range is your satisfaction. But let's put them in order. -2, 2, and 7. Writing them in order. Do they have to be in order? Nah, but you see them in order oftentimes. So these are all my y values. These are my range. Now, let's just draw the link, draw some lines to show how they're related. 3 became 2, 5 became 7, and 6 became -2. Now, if we go from points to domain and range, we can now go back actually, if you have those arrows connecting them. We said 3 goes to 7, 5, so oops, 3 goes to 2, sorry. 3 goes to 2, 5 goes to 7, and 6 goes to -2. See, we're just following the path. Now, to talk about this, you could say, like, if I had 3, I would feel pretty good too. But if I bought 5, man, I would feel really good, 7. But if I bought 6, oh, this will give me a bad tummy. So the idea is your inputs give you one output. And those outputs could be anything. Let's try another one. If I put 3, 2, 5, 7, and let's do 6, 2. You guys can hear that screaming in the background. It's my son. 3, 5, 6. And what are the possible y values? There's only 2. So if I buy 3 for dinner, it would make me feel a happiness of 2. If I bought 5 for dinner, it would give me a happiness of 7. But if I buy 6 for dinner, this would give me a happiness of 2 again. So looking here, which one should I buy? I should probably buy 5, right? So for functions, it's all about relationships. So you can say a relationship here was dinner. Me choosing what I would like for dinner. This could be to anything. This could be the amount of Oreos that you eat. If you eat 3 Oreos, you feel modestly happy. If you eat 5 Oreos, you're pretty happy. But if you eat 6, oh, I ate too much. No, I don't feel as good. Okay? Now, we have a problem. Here is a be careful. Oops. Be careful. Now, here's the be careful part. You cannot repeat domain values. So these are not functions. 3, 2, 5, 7, and 3, 1. Here's our domain, and here's our range. 3, 5, 1, 2, 7. Make sure you understand where I got these numbers, where I got 3 and 5 from, and where I got 2, 5, 2, 7, and 1. So let's talk about this. If I had 3 Oreos, I would feel a satisfaction of 2. If I had 5 Oreos, satisfaction of 7. And if I had 3 Oreos again, satisfaction of 1. Wait, which one do you feel? If I eat 3 Oreos, should that be 1 or 2? What happens is that relationship doesn't make any sense. You can't have 2 differing opinions for the same activity here. Another way of looking at this as time. I want you guys to look at this as time. Let's go back here, and I'm gonna call 2. Let's say you guys heard of GPS, right? GPS is a location that your phone can help track you. Your parents can track you, right? So 2, that's called as home and school. Okay. At 3 o'clock, the GPS said you were at home. Make sense? At 5 o'clock, the GPS said you were at school. And at 6 o'clock, the GPS said you were back home. Will that be okay? So at 3 o'clock, GPS said home. 5 o'clock, GPS said school. 6 o'clock, the GPS said back at home. Good. You're doing what you're supposed to. Now, the problem is, can you be in 2 places at once? If I said, let's call this home, school, and we'll call this work. At 3 o'clock, you're at home. At 5 o'clock, you're at school. And then at 3 o'clock, you're home. Wait, you're at work? What? How can you be at work at home at the same time? Well, distance learning, we can do it. But if your GPS is saying that you're at work and you're at home, this doesn't make sense. And what happens is the machine is broken. This is not a function. If we talk about functions as direct relationships, for every cause there's an effect. You can't tell me if I plug in 3, I'm going to have 2 outcomes. That is not a clear function to us. That does not work. So an FYI, if you ever see this mapping of a number repeating in the x value, that is not a function. Does not work. Numbers can repeat in my y value, sure, because you could go back to the mall. You can go back to your friend's house, but you can't be in 2 places at the same time. I used to tell this story as dating, right? So, but that's not gonna go there. Okay, so let's go ahead and do this last part. We're going to go ahead and map this stuff here. Not a function. 1, 2, 3. Y value is positive 2. X value is 5. Y value is 7. Just call it 7 up here. And we'll graph the last point, 3, 1. 3, 1. If you think of this as a timeline of your life, okay, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, okay? So at 5 o'clock, you're at 7. At 3 o'clock, wait, how can you be in 2 places at once? So this is not a function. You can't be in 2 places at once. And we actually have something called the vertical line test. And it is a super cheesy method of seeing if something is a function. If you have something called you pass a vertical line. Do you guys how you see my rulers, my vertical line? If I walk from left to right, are there any points that happen twice? If it does, it fails the vertical line test. That means it is not a function. Why am I bringing this up? Is because when something isn't a function, it's actually really easy to tell. If they're on top of each other, it is not a function. Let me give you an example of some graphs. Functions or not a function. So in Algebra 1, pre-calculus, you see graphs that look like line graphs. You see graphs that look like little wavy snakes. You'll see graphs that look like circles. You'll see graphs that look like sideways parabolas. Which of these are not a function? And what happens is, if we just pass our vertical line test, so please everyone look at graph A. For every x that you see, there's only one y value. Only one y value. So this is what we call a function. You're only seeing one y value for every x. Let's see for b, does that still take place? Every time I pass my vertical line test over, for every x value, there's only one y value. Hey, that passes the vertical line test. That is a function. But over here, look at the circle. If I pass my vertical line around, I realize that this fails the vertical line test. Because for every x value, you have 2 possibilities, which is not a function. Over here, vertical line test. Failed. Okay. So it's just a quick way to tell if something is a function or not. The last part of your first IXL problem is going to be this last section here. Let me go ahead and do this. You guys are going to come up with table values. Okay, and there'll be a table of x and y's. And you're just going to fill out the missing part. Or this could be written as an or set of ordered paired. Okay, so both these will work. So if x is 1, our y value is 2. If our y value is 2, our x value, whoops, I messed up here, sorry. Oh yeah, okay. If our x value is, whoops, I meant to erase this. Oops. Got caught up. Put the 1 there. I'm sorry. If y is 2, x is 2. Oh, if y is 1, x is 2. If x is 3, y is 3. And the same thing here. I would have just done, you would fill out the point. If x is 1, y is 2. If y is 1, x is 2. And if x is 3, y is 3. So you're just going to fill out the chart. Okay. Now, we've been working with the idea of y is equal to 2x. Now, we're coming up with this other way of talking about it now, and that's going to be function notation. And it sounds kind of hard. It's a big word. But all it is I am swapping y for x's. Same thing. And the reason why we do this is because if I write f of 2 now, what does x become? X becomes the number 2. So instead of writing x, we just write the number 2. So the way we look at this, x is 2 and y, or f of x, is 4. Because y is the same as f of x. The reason why we write function notation is because you know what's plugged in. Anyone here drink Capri Suns? You guys drink Capri Suns? You guys remember Capri Sun? If you notice on the bottom of a Capri Sun drink, it's see-through, right? You can see what's inside of it. You know that. That's actually only a current thing. Back in the day when I was growing up, they actually, you could not see what was inside a Capri Sun. It was completely silver color. Not often, but you've had it, right? So remember Capri Suns look like this, kind of like a box drink, and it's kind of like cut up and you stick a straw in it. But on the bottom of a Capri Sun, if you tipped it over, it was actually see-through. And what happens is they changed the container a couple years ago, maybe a decade now, so you can see what's inside. Because kids were drinking rotten Capri Suns. What happened was, since it was closed off, kids would just stick the straw in and start drinking it. But you don't know if the Capri Sun's like 10 years old. You don't know if that there's bacteria or something got in the Capri Sun, and then you start drinking swamp water. So here's the idea of our algebra version of that. I'll tell you what to plug in so you know what to plug in. If f of x is 2x, I'm going to just plug in the 3 now. What if f of x became f of 10? We're just going to write 2 times 10. What if the function was bigger? F of x is equal to 3x plus 5. What is f at 2? So we just write 3. X becomes now 2 plus 5. So all we're doing is we're plugging it in and now solving it. So f of 2 is the answer 11. Okay. And that's the only new part about this function notation, is that instead of writing the letter y as my result, we just switched it with the idea of function with the value I'm plugging in. Function at 2, function at 3, function at 10.